What is this made out of? Plastic.
What is plastic made out of?
Plastic is made of a chain of carbon atoms or with nitrogen, oxygen, or sulfur.
But how can these atoms stay packed together? Jesus made it like that.
No chemical bonds.
Bonds. Bonds. Bonds. We the bonds. 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 We the bonds. Like I said, we the bonds. Look, we are the sponge. Call us bonds. Describe the bonds. Include many electrons. Yeah, covalent bonds. Look, yeah. So, covalent bonds hit the crusty crab. Ionic bonds, matter of fact, look at my dad. Metallic bonds, I never learned. The bonds war, matter of fact, welcome to our lab.
2,000 years later.
Guys, welcome to the SpongeBond's lab. Today we're going to be talking about chemical bondings.
What makes up an atom?
I don't know.
Pens, protons, electrons, and neutrons. Pens make up atoms, and atoms can bond to make numerous things like pens.
Elements can take, give, and share valence electrons to form different types of bonds. Valence electron is the electron on the outermost shell of an atom.
The different types of bonds are covalent, ionic, and metallic. Covalent bonds is a bond between two nonmetals. The electrons in these bonds are shared within each element. An example of a covalent bond is H2O, dihydrogen monoxide.
This is a model for water.
This is commonly known as water.
Ionic bond is a bond between a metal and a nonmetal. For example, sodium chloride. That's a model of sodium chloride. And that's commonly known as salt.
The last bond is metallic bonds. This is a bond formed by metals and metalloids that has an attraction between positive metal ions that has electrons surrounding it.
One of the major differences between covalent ionic bond and metallic bond is that covalent and ionic bond forms compounds with different property than the original elements, but metallic bond forms compounds with similar property with the original elements.
Elements want to fill up their valence shells with all electrons. The important difference bonds are double and triple bonds. This is only for the covalent bonds.
Double bond is when atoms share two pairs of electrons, and triple bond is when atoms share three pairs of electrons.
For example, dioxide, also known as oxygen, is a double bond, and carbon monoxide is an example of a triple bond. These atoms work together to complete their valence ring.
The octet rule is an important part of bonding. The octet rule states that most elements gain or lose valence electron to get electron configuration of the nearest noble gas.
Oh, hey.
I'm sorry, I don't like you anymore because your hairstyle is so weird. How dare you slap me?
No one makes fun of my hairstyle except me. Do you want a stronger bond with your partner?
Sure.
Try our valence electron engagement rings.
The stunning rings were designed by famous designers in the elemental world.
What makes it so special? The diamond on the rings are electrons. It can be shared, taken, or given to make sure your relationship is stable.
There are many different types of rings you can buy for you and your partner. If you want to have a bond stronger than our ionic rings, you should buy the double bond set.
If you want an even stronger bond, you should buy the triple bond set.
I want quattro
The
bond.
triple bond set is the highest bond we have at Penn Jewelers.
For example, the salt set is one of our ionic rings.
In this box, you can find sodium rings and the chlorine ring. Together, the bond will be stronger and have more stability for your relationship.
One of the rings you can buy in the double bond set is the oxygen set. This set comes with 2 oxygen rings for you and your partner.
The triple bond set is the most strongest bond to make your relationship stable, such as the carbon monoxide set. It contains a carbon ring and an oxygen ring. Hey, I have a gift for you. Yeah.
It looks so pretty.
Yeah.
I love your hair, actually.
Oh, thanks. Stronger bond.
If the ring is worn for more than 30 seconds, there's a 99.9% chance of exploding. Other symptoms might include growth of pink hair, black belly buttonhole, and sudden death. Wear at your own risk. Penn Jewelers is not responsible for any harm done to the customers. Refunds are not acceptable.
Hello, my name's T.S. Valley, and today I'm going to be doing the home experiment copper caper. For this experiment, you will need 20 dull, dirty pennies, 1/4 cup of white vinegar, 1 teaspoon of salt, a clear shallow bowl, non-metal, 2 clean steel nails, a clean steel screw or bolt, and paper towels. First, put 1 teaspoon of salt in the bowl, then 1/4 cup of white vinegar in the same bowl, and stir until the salt dissolves. When all my salt dissolved, I converted the liquid into a smaller container for this next step. Next, you want to dip 1 penny halfway into the liquid and hold it there for about 10 seconds. The brighter part was where the vinegar was in, and the duller part is where it was normal. Now dump all the pennies into the liquid. You can watch them change for the first few seconds. After that, you won't see anything happen. After 5 minutes, take half of the pennies out of the liquid, put them on the paper towel to dry. I'm taking out half of the pennies. Take the rest of the pennies out the liquid, rinse them really well under running water, and put them on a paper towel to dry. Right, rinse on the second paper towel. After about an hour, look at the pennies on the paper towels. What happened to the ones you rinsed? What happened to the others? What color is the paper towel under the unrinsed pennies?
As you can see, the paper towel with the pennies that was soaked in vinegar and water was green, while the other one was normal with no color.
Weird.
Have adult supervision while doing this. Put a nail and screw into the liquid. Lean another nail against the side of the bowl so that only one part of it is in the liquid. After 10 minutes, take a look at the nails. Are they a different color than what they were before? Is the leaner nail 2 different colors? If not, leave the nails in the bowl and check them again in an hour or so. What's happening to the screw? You may see lots of fizzing bubbles coming from the threads. Is the screw changing color? Leave it in the liquid for a while to see what happens. Let's look at the nail that we left half in and half out. One side is black and this is the side that we left in. And the other side is the normal color. Here's the nail that we left full in right here. And here's the other one. Also, now I took out the screw, the same thing happened to it.
Why does this happen?
That's a great question to ask. Let's ask Kayla.
Everything around you is made up of tiny particles called atoms. Some things are made of one kind of atom. The copper of a penny, for example, is made up of copper atoms. But sometimes atoms of different kinds join together and make molecules, which is also known as bonding. So, copper atoms can combine with oxygen atoms in the air to make a molecule called copper oxide. The copper oxide makes the pennies look dull and dirty because they're covered with the copper oxide. Put the dirty pennies in the vinegar and salt, the copper oxide, and some of the copper dissolve in water. That means some copper atoms leave the penny and start floating in the liquid. But when these copper atoms leave the penny, they also leave some of their electrons behind. Rather than the whole copper atoms in the liquid, you've got copper ions, copper atoms, and copper atoms that are missing 2 electrons. These ions are positively charged. The vinegar and salt, we were able to break the ionic bond between oxygen and copper using acid. Copper oxide breaks down in weak acids, and when you mix table salt and vinegar, it's an acid. You could also mix salt and lemon juice or orange juice because those juices are acids too.
You mean to tell me we just learned how to break an ionic bond?
Yeah, pretty much.
Look, so yeah, okay, we're gonna do it on this track. And I spit it like that. Look, alright. So we start off right now from metallic. Two metals and they still stay classic. Ionic as a non and then a metal. Two different elements, we can make a metal. I think this info is quite salient. Bonding strong when it's covalent. Covalent bonding, that's team playing. Electron sharing, that's what I'm saying. Atoms forming molecules, electrons bonding, and that's them rules. Bonds are so stable, like 4 legs. Matter of fact, call it a table. Certain things, yeah, you should. Covalent bonds sure shine good. So don't forget there might be some odds. See y'all later. Out like the SpongeBond's.